Recording. So welcome everyone. Again, it's part 4 in Introduction to Programming, and again we're going to continue on where we stopped last week. Last week we talked about loops, about repetition with while loop. We talked a bit more about the break statement, and then discussed the new control statement, the continue statement. Then we talked about nested loops, and then some specific string operations, basically about the indexing strings, getting the string length, extracting characters and substrings, and then we had a short introduction to own functions. And yeah, before that, I think I promised to tell you that a little bit about the VS Code, the project we start using, the project, the editor we start using on this week. So starting from week 4, you need to complete all your programs by using the VS Code editor. It's an external editor you need to install. You need to install Python, and you need to install TMC plugin. These are all covered in the instructions, which you can find in the beginning of part 4. So just follow the instructions. There are separate instructions for Windows, for Mac, and for Linux users. So just select the right operating system, and then you should be fine. If you're having any problems in installing this, then I think the best bet is to bring your laptop to one of the workshops, if possible. If you're not in Helsinki, if you can't attend them, then just go to Discord and ask our supervisors there. There are a lot of people who can help you. There are some things that may go wrong even if you follow the instructions, but typically if you follow them, this shouldn't be a problem. I think the most common problem is that if you're using like a company laptop or something like that, where you don't have the admin rights, so you can't install anything, then it might be a bit problematic. But other than that, it should be fine. So again, starting from part 4, you can't complete your solutions with browser alone. You need to install the external editor. And the editor we're using, the Visual Studio Code, it's the one I've been using for these lectures since week 1, and it's a sort of a professional editor in a sense that it's used in a lot of professionals are using it to write code in several languages. And there are various plugins you can install to make it more comfortable for your needs and so on. But the basic functionality is actually quite nice as well already. So it's definitely it's a better editor than the one we've been using in browser. A little bit about submitting the exercises. I can now this is the Finnish version of the course, but it's the functionality is exactly the same. So once you open this, you download the exercises and you click the open workspace button, you get this kind of view where you have all the parts you have available. And then for each part you have there are basically 2 folders, the SRC, which is sorted for source code, and then there's the test folder. And in the source code file, SRC file, or in the folder, sorry, there's a file which you're supposed to edit. So this is for part 1. You can also keep on doing this part 1 to 3 in this editor if you want to. So this is the first part exercise where you were meant to, or where you were supposed to calculate the number of minutes in a year, which was a simple multiplication. But just an example, so you can execute this code as much as you want to by using the play button in here. You can make modifications, you can do whatever you want to, and when you're happy with your solution, there are these 2 TMC buttons in here. This one opens the action menu, but the one with the icon is for running the tests. So when you click it, it executes all the tests for this one. It displays which one you passed and which one you didn't. So it's similar to the you had in browser. And when you are happy with that one, the Zoom controls are always on the way. You can click the Send Solution to Server button, which then submits your solution and shows whether you passed this or not. And when you pass this, then also in the browser, the red border turns to green, and you can say that you can see that you got the points from your solution, and you can also see your points if you click the little blue button in the bottom right corner, which displays your current score in this MOOC. So this is, I mean, this is pretty similar to what we've been doing in the browser, but now we're just using the editor for this one. There's the show model solution in browser button as well, and if you click at the DMC accent button, well, there are I don't think you actually usually need any of these. So this is basically like the functionality you'll be using. And again, please use the Discord or workshops if you're having any problems with this one. But it should be quite logical, and I sort of prefer this. At least I prefer this one to the browser version. But the reason we start this in browser is just to make starting this course as easy as possible to you. So you don't need to install anything in the first week. But now, when you have some experience in programming, now it's time to move on to actual tools, like proper tools. Okay, let me get back to. Let's take that one. Okay. This is definitely not like so we had last time, but it doesn't matter. Okay, so last time, again, if you have any questions about this, now you can ask them away. But so let's continue. So last time we talked about functions, and we basically ended with something like this, or let's say I'll put some, and there's number 1 and number 2, and then sum should be property sum of numbers, I think. And if you're wondering about this one, you can rename these variables in this editor quite easily by clicking, at least in Windows and Linux and Unix, I think F2. So if I click, if my cursor is on the in top of a variable and I click F2, it displays this little window where I can give a new name to the variable, and then it says all the occasions of using that variable to that name, which is very, very, very handy if you have a longer program, especially. Yeah, so I try to remember to tell you whenever I'm using one of these, and also you can ask if you see me doing something which I don't explain, because I'm used to using some of these shortcuts and I don't always remember to explain them. So basically, anyway, this was what we were doing. We were talking about functions, which are also called subprograms, which is an appropriate term in a sense that it's like a smaller part in a longer program. And then when we have written a function, we can then call the function by providing different values for parameters. So if we execute this with this one, we get the sum of number is 30. If we provide different parameters or different arguments, let's talk about those in a minute, we get a different result. Let's simplify this a bit. Let's just output the sum of numbers at this point. So now we need to discuss some important terms before we move further. And these are the ones we're going to use quite frequently starting from now. So the variables defined in this line where we define the function or the subprogram are called parameters. And this actually shows, if you can see the tooltip in here, it shows the parameter number 2. And there's something else. It also shows that it can be of any type. Let's talk about that in a minute. And then the values we pass to those variables are called arguments. So we pass the argument values to parameters. Let's see, here's a multiple versions, but let's say that we have two functions, greet with one parameter name and sum with two parameters a and b. And whenever we call the function, we must pass the argument values to those parameters. And now parameter is a function. And let's simplify this a bit more. Let's do something like a greet one. So now when we calling this function, we need to provide an argument value to this parameter variable message. And now it's a variable, and it's a variable like almost any variable, in a sense that because it's a variable, the value can change. We can do something like this. And now when we execute this one, we get the word hello followed by 5 exclamation points, something like this. So we can change the value of this message variable because it's a variable. What makes it different to other variables we've been using so far is the fact that when we define this variable, we don't provide a value for it. So it's like it is a variable, but it doesn't have a value when we are writing this function. And the value is passed when we call the function. So we provide this argument value when we call the function. And we can call the same function with different parameter values. So we can execute the same function several times and provide different argument values to those parameters. So we define a variable, but we don't specify a value for that variable. Another thing that's different to other variables is that the scope of this variable is limited, meaning that this variable is only visible inside this function. So if I execute this function and then I try to output the variable message like this, we can already see that there's this yellow underline indicating an error. And if I try to execute this one, it displays a name error stating that name message is not defined, or in here is message is not defined. And the reason why Python states that the variable is not defined is because it's only the variable doesn't exist outside this function here. So we call that variable a local variable of that function. So the variable is only exists inside that function. And same applies actually to any variable we initialize inside a function. So let's do something a bit different. Let's do like a sum of values again. Value 1, value 2, and then we can calculate result equals value 1 plus value 2. And then let's output the result. And again, if I execute this one, sum of values, let's provide a couple of numbers. If I try to output the result variable in here, again, that's an error because this variable result only exists inside this function here. Again, if I try to execute it, I get a name error stating that the name result is not defined. The name result doesn't exist in this location of the program, in this main program. So it only exists inside that function. And this is something you need to know. It's something that's useful in some occasions. It's also something that can create errors in some other occasions. It's something I'm going to talk about a bit more later as well. But the meaning that all these variables, value 1, value 2, and result are only visible inside this function here. Let's do something a bit more useful, maybe. Let's write a function for factorial. Let's go to number. And now let's state that we're writing a function which is going to calculate the factorial of given number or value. And now I'm going to show you something which is probably covered in the material a bit later, but I think is useful. So this is a very special kind of comment we can add to functions. And the idea is that it's a single string. These three quotas indicate that the string can actually spawn multiple lines. Again, it's something we're going to discuss later a bit more. But the idea of using this string is that, let's just return something. Just going to show this to you. When I'm calling this function now, you can see that Python or the VS Code displays this comment as a tooltip in here. It displays the calculate the factorial number of exclamation of number. And this is useful, again, when you're writing a longer program, when you're calling a function, and so it gives you like an overview of what is the idea of a function, what it's supposed to do, what it's returning, and maybe what it like requires as a parameter and things like that. So this single line of comment is there just to like provide anyone calling the function more information about what the function does. And I think it's a good idea to start writing these two functions from the very beginning. So it's again, if you're just writing a single function and you're testing it, you probably know what the function does. But what I'm trying to teach you here is the fact that hopefully at some point when you're a bit more experienced, you're writing longer programs, you may be returning the programs you've written yourself, and at some point you start writing programs with other people. Because that's what we typically do. I mean, nowadays the programs are usually so large that it's really rare that one person writes the entire program. And when you're writing a program with someone else, then writing a code that's as easy to read as possible is really, really like an important skill. It's really great to write code with people who actually know how to comment and document the code and write code that's as readable as something. And that's what I try to. I'm talking about that occasionally or quite often actually, that the fact that you want to write code that is as readable as possible and including proper comments is a definitely way to that one. And this special kind of comment is useful in Python because then when I'm calling the factorial, I can see that one, or calling any function, I can easily see what is like the main function of the function, something like that. Yeah. Okay. Anyway, let's do the function. Let's say that equals 2 and the result equals 1, and while smaller than or equal to number, I don't know if C is we multiply the result by C and then increase C by 1, and then we output C. Does that make any sense? I hope it does. Let's try this one. Try factorial of 3, which should be no, there's something wrong. Let's see. You can also debug this with me. So we multiply it by 2. Oh, it's supposed to output the result, of course. So the factorial of 3 is 6. The factorial of 5 should be 120, and the factorial of 6 should be 720, and so on. So it seems to be working. In this case, I'm using this one letter variable, although I don't think it's a good idea, and I think we can change the name of that one to something like a multiplier, for example. But the reason why I'm using it was that the factorial algorithm is quite common, and we usually use like n and c and this one letter variables. But it's I think it's always a better idea to use like variables which carry a meaning, where the name implies the content of the variable, like in this case. Okay, so this seems to be working, but there's a question which is how to upload our homework we do here to the web page. Yeah, I actually saw that in the beginning of a lecture. I can probably do it at the end as well. Again, if you want to, or you can check the recording. We started with that one, but maybe you weren't present then. But I'm not going to do it now because I need to switch to different workspace, and then I'm going to it's a bit of a hassle, but I can do it at the end of the lecture again. So no problem. Just remind me at the end. So this factorial thing seems to be working. Let's say that we want to calculate the result of factorial 5 plus factorial 3. So I want to know what is factorial 5 plus factorial 3. How can I do it? Can I do it by using this program? Or what should I do to come up with the result by using the code I have in here?
Can we use like two variable outside the program? That can be one way. Like like say a equals to def factorial and then 5.
One is talking, but I can't hear anything. So if
Can you hear me?
There might be an audio problem or something. So just type in the chat window, and at least at the moment I can't hear.
What about now? Can you hear me?
So if you can hear, then the problem is probably on my side. My side it seems to be, but since I can't hear you, you probably just need to type in the chat window. Two variables, yeah. But how can I use the two variables where the function is used? Okay, but how can I use the function with variables? Because I can try to do this one. What do you think this will output? Because you're on something here, and you're definitely over there, but it doesn't output 120. It does output 120, but the variable res1 contains value of none. And the reason for this one is that the function factorial, it outputs the result, but it doesn't actually return anything. It doesn't, the call the function factorial doesn't get the value of anything. And for example, we're going to need something new, and I really like what we were answering over there. You were definitely on the right track. We just need one more tool, and it's the return. And the idea of a return statement is that the function, instead of outputting something, it can return a value. And then that return value can be used as a part of an expression. And we've been using return values before. For example, we started in the first week with something like using an input statement and then using an int function or input function and then using an int function. And in this case, Python first executes the input function, which queries the user for the string, which is then returned, and then Python calls the int function, which converts the value into integer. So instead of printing out something, we're going to return the result. And let's see what happens. Let's first just call the function without doing anything with the return value. And if we do it like this, then the program doesn't output anything. The reason the program doesn't output anything is that we don't have any print statements. And the way to output something in the console is to use the print statement. Okay, so what we can do with the result value or with the value returned is use it in an expression. And the simplest way is just to store it into variable, something like this. And then if you want, we can output the value just to show that the value is over there. So now it outputs 120. And at this point, this is exactly like what our entire program did before we started using the return of just printing. But the upside of this is that now we have a value which we can actually use as part of an expression. So we can use it and we can store it into variable. We can add something to a value. Let's add 10 to the value. So we get 130 instead of 120. We can multiply it by 100 if we, for some reason, want to do that. We can, of course, output it several times. Well, we of course need to call without calling the function again. So we can basically store the value in a variable. But we can also, what we can do is, well, let's call the function a couple of times. And now we can calculate, yeah, that's a really good question. It's a really good question, and we're going to get that in a minute. We were trying to calculate factorial 5 plus factorial 3. So now we can say that factorial 5 plus factorial 3 is equal to res1 plus res2, like this, and it's 126. Or we can calculate this with a single statement, like which we had in the chat window already, like factorial 5 plus factorial 3, and then we can output the result like this. And now, important thing to consider in this one, that we do have a variable result here, and we do have a variable result here, and these two are different variables. They have the same name, they have the same type, they even might have the same value at some point, but they are totally different variables. Changing the value of this result has no effect on this variable here, and changing the value of this variable has no effect on this variable here. So we can have variables named similarly in functions and in the main program, but those are different variables. Okay, so this one should work. We can also simplify this even more by just using the function calls in the f-string. So we don't even need to use an intermediate variable like this. There's also a question, can we define the variable result before defining the function, like you mean in somewhere in here? Yeah, we can do that, yeah. But the one thing I sort of recommend that when you have functions in your program, define the functions before the main program. So don't do this. So don't define any variables before the main program. Well, except like there are some special cases, but we're going to talk about those in the advanced course. So it's a good idea to have all your function definitions in the beginning of the program, and then you have the main program where you call the functions, and the functions may call other functions or so on. And the reason there is no syntactic reason. In some languages, you need to do this. You can't call the function before you define it. In Python, in some cases, you can, but I think it's a good idea to have those functions over there because it's easier to locate them in the beginning of your program code. And so when you need to do some fixes to a function, you know where to find it and so on. Also, in Python, actually, in this case, you can't call the function before you have defined it. So in this case, this is a problem. In some special cases, especially when we talk about classes and stuff like that, you can actually do this. But in general, I would say that start the program by defining the functions and then have the main program after that one, after those. Okay. So let's take a closer look at what happens here. Now, this whole return or print can be sometimes difficult at first, and it's really typical that we encounter solutions where you think that your program is working, but you're not returning something when you should. You're printing something instead. And a good sort of rule for this one is that if you want to use the result value, return, if you want to use the result of the function as part of any expression, then you need to return it. And I'd say that this covers like most functions. So it's almost always a good idea to return something. There are special cases where you want to print something instead of returning in the function, but usually it's a good idea to return something, and then whoever calls the function can decide what to do with the return value. So if you just print something out of a function, then we get the result on screen, but we can't use it as part of any expression. But if we return something, then the caller can decide what to do with the expression. And what happens when we call a function with a return value, you can think that this function call is sort of replaced with the return value, and then Python calls the factorial again, and again this function call is replaced with the return value, and then these are calculated, and it becomes, no, I'm sorry, 126, not 726, but anyway, you get the point. So when you have a call to function in an expression, Python executes the function, and then the return value will replace the function call in the expression. Hope I'm making some sense here. I know this can be somewhat sort of difficult at first, but you will definitely get the hang at some point. Okay, because a function returns a value, and in this case, we can also function also receives an integer as an input. We can also do something like this. So what is the value of result, or what value is stored in the result? You don't need to specify the exact value, but like how is it calculated?
Factorial of 6, 120.
Can't hear you. So if just use the chat window. Something wrong with the headphones, and I'm not going to. I probably need to restart the whole system, and I'm not going to do it now because we're wasting time. It's probably going to be a bit more than 120, but the basic idea is okay. Yeah, and the factorial of 6, I think that's 720 actually. But yeah, still you got the point over there. So what happens here is that Python first executes factorial with input value of 3, and then which returns 6, and then it calls the factorial again with input value of 6. And we can actually see it if we output the result here. So now we can see that it first executes the function factorial with input value 3, and then it executes the function factorial with input value 6. So it actually executes the same function 2 times with different input values. So we can nest these function calls in some occasions if the return value and the parameter are compatible. I mean, they are not compatible in all cases, but in this case they are. So it's possible to calculate the factorial of a factorial, and go on, but we do get a very big number if you try to calculate the factorial of this one as well. Let's see if it actually works. Well, it does, but you get the point. The number is quite large. Also see that the Python still calculates this rather quickly, although the number is quite large. So it's basically the factorial of 720. Okay, so let's move on a little bit. So basically the return is I'd say, as I said before, like as a general rule, I said that whenever you're writing a function, it's probably a good idea to return the result unless you're explicitly stated to do something else, or unless there is a really good reason to not output anything. And next week we're going to talk about side effects, and then we're going to see some examples on cases where you don't necessarily need to output anything. But I think most of the time function is supposed to return something. Also get the function like has a value of something with some input. And this is actually quite close to how functions work in mathematics. So we have some kind of input value, and we have some kind of result like fx equals something, and then if x is something, then the result is something. So this is pretty similar to that mathematical concept. Okay, let's do something a bit more simple, and let's see what kind of problems we can have. Okay, now let's return something. So let's start with a simple question. What does the program output? Suppose that this wasn't the trick question. So it outputs 100. We can see it if we execute it. Let's change this a little bit. Let's say that we're A and 3. What does the program output? It's A. So in Python, we can multiply a string by an integer. And what it does, it repeats that string a given number of times, which is quite handy in a lot of occasions. So we can, for example, multiply letter A by 3 times. Well, that isn't probably handy, but we can do something like multiply an asterisk by 100 times, and then we get a longer line of asterisks or whatever. And then this is useful when we're drawing this sort of kind of ASCII images or things like that. Okay, so this is cool. How about this one? What is the outcome? It's an error, yeah. We're trying to multiply A by B, and A times B is something we haven't, Python isn't defined in Python. And I think that's logical because A times B isn't something we're usually multiplying. If those are variables, then it might be different, but letter A times letter by times letter B is not something we can do. The problem with this one is that when we call it to multiply, it doesn't really give us any information on what kind of variables we should pass to this one. And in Python is something called a dynamically typed language, which I think we probably discussed briefly before. But the idea is that in Python, when we define a variable like number equals 10, Python automatically detects the type of the variable based on the value we store in that variable. Yeah, A plus B equals AB, but A times B doesn't equal AB. Yeah. So if we store value 10 in variable number, then Python now knows that the type of the variable number is an integer. Or if we store a floating point value in a variable, or if we store a string in a variable or whatever, then Python knows that the type of the variable is that type. And as a programmer, we also know that. When you define these variables in your programs, you then know that okay, the type of the variable number is an integer, and or this one is a floating point, or this one is a string, and this means that there are certain kind of operations we can use with those variables. So we know that when we have numbers, we can add them and multiply them and divide them and use any number operations. Or when we have strings, we can use the string operations we discussed last time. When we can extract characters or get a length of the string or something like that. There was a question when 1.5 times A is given. No, that doesn't work either. You can't multiply a string with a floating point number. So you can multiply a string and an integer, but you can't do 1.5 times A. Yeah, because I don't know, what would that be? Like what's half an A? Half an A could be actually like half of A, but 1/3 is even more tricky. And half, well, yeah. Good question. And this actually underlines our problem. So this is actually quite cool, and having a dynamically typed language in this sense isn't bad. There are also statically typed languages like Java or C or C++ or C Sharp or Rust or whatever, where you need to define the type of the variable explicitly. So you need to state that this is an integer variable, and or this is a floating point, or this is a string. And so it doesn't automatically detect that based on the type. Now, the problem with dynamic typing is when we define functions. And like we talked before or earlier today, when we are defining a function and these parameters for the functions, we are defining variables, but we don't provide values for those variables. And now this is a problem in the sense that because we don't specify values for these variables, we don't know the types of the variables. I mean, the types are not obvious in this program in here. If you take at the code, then you can probably get or sort of understand that, okay, this can't be strings or something like that. But if it's a bit more complicated function, it might be difficult to sort of get the point at what kind of values you can actually store in those variables. And for that reason, we're going to have something new, and something called type hints. And the idea of type hints is that we tell what kind of values we expect for these variables. And we do it by providing a column and then the type in here. And the types we can use for this one are, some of the types are listed here. So we have int for integers, float for floating point numbers, str for strings, and bool for Boolean values. And these should look familiar to you because we've been using these as functions. So we've been using the int function to convert something into integer, and the str function to convert something into string, and so on and so on. So we can use these. Yeah, I can give an example of bool as well. That's a good point. We haven't been using Boolean values as much. So what this means now, again, when we're calling this one, say that we are saying that result is multiply, and now when I'm calling this one, we can see this tooltip stating that the function multiply has two parameters, first and second, and they are both integers. So both of the type of both these variables is int, sorted for integer. It also displays the return value of this function. So there's this sort of arrow in here and int stating that it returns an integer. And when you're calling this one, it's now easy to know what kind of values we should pass to this function. And now this is a hint, and because it's a hint, it means that it doesn't force you to do anything. We can still provide a string as a value. It might work, it might not work, but the original idea was to provide two integers. There's a question: can given hint to function be problematic sometimes? No, I don't think it can sometimes be problematic to decide on what the hint should be, but the hint itself, no, I don't think. I think it's almost always a good idea. It's difficult to come up with examples where you're not supposed to do this. And if you can provide any value, you can just specify it by stating any. Actually, you don't need to specify it because Python does it for you. And so it can be any type, and then the second one is an integer. But almost always we are requiring like specific types for those variables. If you want, we can also specify the return type. So in this case, Python may not recognize it itself. In this case, it actually does. But if you have a more complicated function, it may not. But we can specify the return type in this definition as well. When we were designing this course with Matti and Antti a couple of years ago, we decided to omit these return value hints in most cases. I think it's mentioned in the material, but it's not used in most cases. I'm sort of used to using it occasionally, and I may use it at some points. It's a good idea that you know what it means, but starting from this point, we are requiring you to use these type hints when you are doing function. And it's a really good idea. And again, this comes down to the fact that reading the program code is a lot easier when you know the types of the variable, what the types of the parameters should be when you are calling this, or types of the arguments should be when you are calling this function. So it doesn't actually change any outcome of the function. It doesn't have any result on the outcome of this function, but it makes calling the function easier for programmers, whether it's you or someone else using your code later, or someone else collaborating with you later, or something like that. Again, whole idea is to make the code more readable, make the code more understandable, and to prevent errors. So it's easier to avoid errors when you know what kind of values you should provide for this one. And if you combine this with just the value of first times second, I mean, this whole function isn't probably that useful, but when we combine this, when you can now see that it displays the description, it says returns the value of first time second, and it displays the types of variables, what they should be. So they should be both integers, and then displays and it also displays the type of the return value. There was the question, if function is called but no parameter is given, in this case, is the answer 0 or nothing? That's a good question. And actually, we can't call this function without providing values for parameters. This is an error. And if you actually try to do it, it displays an error stating that multiply missing 2 required positional arguments first and second. So parameters are not optional. Parameters is something you need to provide when you call the function. And this is and I think that's a really good question. So if there are 2 parameters defined for this function multiply, you need to provide 2 arguments when you are calling it. It's an error otherwise. And that's actually quite logical, because you can't really calculate the result unless you have values for both of these variables. So that's a really good point. That's something I forgot to mention before. I think that the values, those arguments are not optional, they are required. And it needs to have exactly 2 parameters. It can't have one. This is an error. And if you have more than one, then this is an error as well. Again, it takes 2 positional arguments, but 3 were given. That positional is something, it actually has a meaning in this one, but it's something we're going to discuss later in this course. But basically, you can read it that it takes 2 arguments, but 3 were given. Okay. So from now on, let's do type hints. Then I promised to give you something about the Boolean value as well. And Booleans are probably not used as often, but we can have something like what would be a good something. Let's do a function about something strings. Let's get like the first word and let's have a sentence, and let's do this without the boolean first. And let's also write the description on this one. And now if we want to get the first word out of sentence, I think we did this last time, so we can search for the space. First space is, and then let's use the find for this one. And then when we know the index for that one, we can get the first word, and then it's from the sentence, from the beginning until the first space. And then we can return the first word. Let's try this out. Query the user for a sentence. Let's see if it actually works. Let's give a sentence. Red fox is sitting in the forest or something. Doesn't really matter if it works. And it says the first word is red, so it seems to be working in this case. Again, now you may ask, why not print the result in here? Why do we need to return the result and then output it here? Again, the reason is that when we do it like this, then we can use the same function in various occasions wherever we need the first word. In this case, we want to output it. In some other case, we may want to collect all the first words somewhere and do something with all of them. And when we do it like this, when we return it instead of outputting it, then whoever is calling the function can decide on what to do with the result. So we're not limiting the use of the result. We're just returning it, and then the caller can decide on what to do with the result. And then about the Boolean. Let's see that we want to change the behavior a bit, or want to have an optional behavior whether we want to include the space after the word. So let's say that when you're getting the first word, in some cases, you want to include the space after the word. In some cases, you don't. So it might be a good idea to just provide this opportunity for the user to decide. And then we need to take the because this is actually something that might have a meaning in a lot of cases, and oh, again, last word, something like this. And now when we're calling this one, we need to provide true or false based on whether we want to include the space or not. So now we also need to provide a true or false value to this include space variable. And Boolean variable is like any variable, but the value is limited to Boolean type variable. There are only two possible values, true or false. So in a lot of functions, you may have these like optional parameters which have like a true or false value, sort of this, we also call them flags sometimes, which give the user a chance to change the behavior of a function somehow. Again, I think we're going to talk about this a bit more when we talk about files, for example. Okay, hopefully this answered the question about the Boolean parameter. Then I think this is pretty much, that's a good question. Is there a way to make second parameter optional? There is, but it's something we're going to talk about a bit later. I can actually, but this is not, I can show it to you, but it's not for this week. We can state that include space equals false, for example. And now when we call this, we can call it without providing the value for second parameter, or we can call it with providing the value. So now this both work. But this is something I'm going to cover in I think in the 6th or 7th lecture. That's a good question anyway, and it is possible. But you don't need to know it yet. But there's no problem if you know it. I mean, oh, good question. Is it good to store the return value in a variable, or we just call the function with print? It really depends on what you're doing. If you just want to output it, then by all means, just output it here. You don't need the variable. If you want to use it something else later, then use the variable. That's like the whole idea. If you just want to output it, then no point in using. In some cases, you may want to use the variable if your line becomes too long because the function names or the sentence you're outputting are long enough. So it might make your code more readable. But if you don't need the value for anything else than outputting, then just call the function inside the f string like this. If you're going to need the value later for something else, like you're using the first words for something other. We're missing a parenthesis over there. That's an error. So if you're going to need to value something later, then you need to use the variable to store it. There are very good questions again today. I'm really happy. I'd say I'm not comparing, but I'm still saying that you might have a bit even slightly better questions than the Finnish version of the course. I really like what you're asking, so keep asking. So that's really good because can't remember to mention everything, and that's why it's good that you're asking these things. Okay, then let's move on. I think this is what we need to know about functions at this point, and this is This pretty much covers the functions in a lot of sense. There are some things we need to discuss at the next time about references, but let's save that to the last time. And then let's talk about something else, and let's talk about data structures. And now let's consider a case where we want to manipulate a bunch of, let's say that we have a bunch of results. And let's say that the results are throwing the dices in Yahtzee or something. So say between 5 and 50 or something. So we can use variables like we've been using before. If we have a lot of these results and these keep on going until we have a bunch of throws in a Yahtzee game, 120 plus 33 or something. Now this isn't any Python program thing, it's just denoting that there are a lot of these. You get the point that writing these result functions one at a time is really time consuming. And then if you want to do something with all of these results, then we need to provide all these variables one at a time. Let's say that we want to find the highest result. And if you have 120 result variables and you want to get the highest, then you're going to need a lot of if statements, like a massive amount of if statements. And you're not going to want to do that, and especially if we have like 1 million results, then you get the point. You're not going to write all those if statements to get the biggest one. And you don't want to write those variables one at a time and so on. And that's why we're going to have something, or that's why we have something called data structures, where we can store multiple values in a single structure, which we can then store into a variable. And we start the discussion about data structures with lists. And a list is a collection of similar type and items with similar meaning. And we can create, we can do exactly that. And that's what we are. This question, can we just arrange in ascending and then find the last value? Yeah, and that's what we are doing now. And for that, we're going to need a list, and for other things as well. But so we could have a list of results. We can call it results, and then when we define a list, we use the square brackets, and then let's say that we have, can't remember which were the values I was just using, but something like this. And now we have a list of items stored into a list. We can output the list. Let's start with something really simple. So it just displays these values. But now list is a dynamic data structure. So we can do a bunch of things with that list of items. We can get a single item just like we extracted the characters from a string. So something like this gets us the first item. No, there was some, sorry, the wrong. So we use the brackets for that one. So if you output this one, it outputs 10. How about if we change this to -1? What is the outcome? It's 24, exactly, because that's the final item in a list. And again, we can't get an item that's not in a list. So if we try to get an item at index 10, it displays an error stating that the list index out of range. Fortunately, we can get the length of the list by using the len function. So this returns 8, if I'm correct, because there are 8 items in the list. So a lot of list operations are actually similar to the operations we used with characters and strings, or substrings and strings. But what's different is that lists are actually dynamic data structures, meaning that we can add items to lists. So we can use the append function, and let's add something like 5 at the end of the list. And now if we output the list, you can see that there's one more item in a list. The length of the list has increased by 1, and there's a new item at the end of the list. So this isn't possible with strings. You can't change a string. You can create new strings out of existing strings, but you can't change a string. But you can change the list, and the whole point of lists is actually the fact that they are dynamic. So we can add items. We can also change items. So we can assign values into a list. So we can state that, okay, the first result was wrong. It should be 11 instead. And now if we output the list, you can see that the first item was changed to 11. So you can change an individual item in a list. Again, the indexing, as we talked about, starts from 0, or if you start at the end, then that's -1. Yeah, you can add an item in the middle as well. So instead of appending, we can insert items. And let me just make another list. It may be easier that way. Let's say that we have numbers 1, 2, 3, 4, and 5, and we want to add a number in the beginning. So we can do something like numbers insert, and then we provide the index, and then the item. And if we do this one, then there's a new item at the beginning of the list, and all the other items have been moved one step forward. And you can insert it at any point. If you want it sort of in the middle, we can insert it at index 2 and so on. Again, so I think I have a slide about this one. So if we insert an item, good question. List like vector, can we do 2 times list and every value becomes 2 times? No, we can't do, or we can do that, but we need to do that for individual items. List isn't a vector. It's somewhat similar with some features, but it isn't a vector. So changing an item doesn't have any effect on any of the other items, and we can't do this like whenever we're manipulating list, we are basically manipulating it one item at a time. Although we can do that to whole list. Well, that's maybe a bit confusing, but yeah, we can use the loop to multiple each value. Basically, yeah, we can actually do that. So anyway, about inserting, in this case, because we're inserting something at index 2, then all the items in this list starting at index 2 are moved one step forward. Now, if you have a really long list, then inserting something in the beginning then can take a really long time, or at least relatively long time. And the reason for that is that Python actually needs to move all these items one step forward. So if you have like a list with 1 million items and you add an item in the first position or in the first index, then Python needs to move all those 1 million items one step forward. And depending on a lot of things, that can take actually seconds, or if you have a really long list, even minutes, or maybe even more. So or maybe even several minutes or hours or something like that. So this is something you need to consider. Again, this is something that's discussed more in the data structures course, but it's an important thing to know that in some programs, if you're using insert, if you're manipulating the beginning of a list or early indexes of list, then those might take a long time if you have a really long list. But yeah, good question. What if we want to multiply all values in a list by 2? Let's do this traditional way. Let's create an index. Let's state that as long as the index is less than the length of numbers. Oops, let's not do that. Do that. And then we can state that numbers index, and we want to multiply it by 2, and then just remember to increase the index by 1. And then when we do this, after this one, we should have a list where all the numbers are multiplied by 2. So we can quite easily manipulate all items in a list by using a loop, because that's what loops are meant to do, to go through and do something multiple times, and they are especially useful when we have a structure where we have sequential items and we can want to do something with all of those items. We can also remove items from a list, and now I'm presenting all these features quite quickly, and the idea is not that you remember all these possible list methods after this lecture, like what was the append and what's insert and what pop and what remove, and I'm showing just examples about these, and then when you start using this, then you remember this. And being a good programmer isn't actually about remembering all these details and remembering all these methods. You need to know the basic functionality and ideas, but if you can't remember on how to remove item from a list in Python, just type it in Google, like remove list, remove item Python, and the first result will definitely be the one to tell you how to do that. And that's also something that's really typical and useful in programming, regardless of whether you've done it a lot or not that much, is to search for information and remind yourself how to do things you haven't done in a while and so on. So I mean, you don't need to remember everything to be a good programmer, but you need to be able to find information to be a good programmer. And you need to know the basics. You need to know like what is a loop and so on, and how to use them and things like that. List, and now let's not call these vectors because they are not vectors. There are vectors in Python in the library. We're not going to cover them, but the list result, that's a good question. It's not used for anything at the moment. I just left it there because we're going to do something with it in a minute, but I just wanted to have this like a easier list because it makes understanding, for example, this multiplication or adding or inserting a little bit easier. We'll get to this one. If you want to remove something from a list, there are two ways to do it. First one is to provide an index. So we can say the results.pop and then provide an index 0. And after this one, it has removed the index at index 0. So what was the item that was removed? Yeah, it was the one with value 10. So we know the list. Now the first item is 22. And the list has only 7 items. If we remove the final item, then it removes 24 from the end of the. So pop is useful if you want to remove an item at a specific position, at a specific index, to be precise. There's also another method, which is remove, which is useful if you want to move an item with specific value. So let's say that we want to get this 31 removed, and so this one removes that specific item. The problem with this one is that if you try to move something that's not on the list, for example 30, and this is an error, it says the list remove XX not in list, so you can't remove something that's not present on the list. In the list, I think. Also, the sort of possible problem with the remove, yeah, that's a really good, that's exactly what I'm talking about. Will it remove all items with a given value? No, it doesn't. If I do results.remove 10 for this one, and let's output the results, you can see that it only removes the first 10, like this one, but the other 2 are still there. What would we do to remove them all? What could be the solution to this one? Let's create a loop. We know how to create loops, and in programming, like combining things we know is usually the answer. Again, something we've been talking about before. Combining simple operations can result to or can be used to solve a more complex problem. So if you want to remove all 10s, let's create a loop. Let's say that while 10 in results, and then results.remove 10. And that's all it takes. So as long as there's this item with value 10 in this list of results, let's remove that. And then after this one, it has removed all the items with value 10, hopefully. Yeah, it seems that it worked. This is also great because it doesn't matter if the item is not there at all. If you say while 11 in results, and this is the item we want to remove, there is not an item with value 11, but this is not an error because if this is false to begin with, then this block is not executed at all. So it doesn't try to remove anything because 11 is not in the results to begin with. So this simple 2-line loop is actually really useful when you're removing something, if you always want to remove all the items with the same value. And I think that is actually quite sort of typical that if you have whatever your list is holding, that if you want to remove an item with a specific value, then it's likely that you want to remove them all, not just the first one. So we know how to add items, how to remove items, how to get the length of the list, and so on. So let's get back to original problem that we want to find the best result. Now we only have like 8 results, or how many there are? Well, there are more. But easy way to do this is to sort the list, and we can use the sort method. Let's just see what it looks like after that one. So this one changes the order of items. So now the order of items is changed so that the first item is the smallest item and the final item is the last item. The order depends on the types of the item. If we have a list of names, yeah, we can use max as well, but we're going to talk about that a bit later. Let's have a name list. We can also sort a list of names. And those are sorted in alphabetical order, or usually in alphabetical order. So now we have a list of names in order from Anne, Benjamin, Greg, Eliza, and Paul. So that's also useful. And there's a question, can we use max? And yeah, we can use max, of course, to get the maximum value. But I think I'm going to present or discuss those max and min and some functions a bit later. Again, a good question. What if we have different cases? And yeah, this one will definitely mess it up. What do you think? Which one comes before, Anne with a capital A or Anne with a lowercase a? Lowercase would be logical, but it isn't actually the one with the uppercase a comes before, and then the one with lowercase N is at the end. And the reason for this is that in character map that Python uses and all the basically we use for any encoding, all the uppercase letters are typically before the lowercase letters. So the uppercase letters are, if you do something in alphabetical order, then we first have uppercase letters and then the lowercase letters. In practice, when we are, for example, sorting a list of names, it's a good idea to change them all in the same case before doing this. So, for example, change them so that the first letter of each word is a capital letter. Let's get back to that one later as well. Okay, so this is useful, but then there are some occasions where the order is actually meaningful, meaning that we don't want to change the order of the results. Instead, we just want to get the highest one, or we want to get a different list where they are sorted. And for this one, we can use the sorted function. And if you do it like this, then the upside is it doesn't change the original list. So the original list remains intact, but we get a new list where the items are sorted in from smallest to the largest. And now we can get also the best one, like the item at -1 is now the best item to 41, but we still have the original order intact. We can do this one as well. So we don't need to use any intermediate variable as well. So that one work that gives us, because the sorted results returns a new list, and then we can get the final item from that list, which is the biggest one, because they are in order from the smallest to largest. In string, how we find a name with specific letter without loop or with loop. Are you talking about string list, or like what do you mean? If you have a list of strings and you want to find a name with specific letter, you need to create a loop. There's nothing I mean, that's the result for that one. Just create a loop and then go through the names until you find the one you're looking for. We can take a look at that in a minute when we talk about iteration. Actually, talk about iteration now. So we've been using this while system to iterate through these items before. We just saw an example about multiplying all the list items by 2 by using the while loop. There's another loop we can use with lists, which is a for loop. And the idea of a for loop is that it makes things a lot easier to, in some cases, if we have a sequence and we want to go through all items in that sequence, it's also something if we call a definite repetition or definite loop, meaning that we know how many or we know the number of iterations. We know that we want to go through all items in a list and we want to visit each item exactly once. Then a for loop is great. While loop is great when we're not so sure about how long we want to keep repeating something like it depends on the user input or something like that. But let's say that we want to output all the results one at a time. And the easiest way, I think, to do it is by using a for loop. Just say something like for result in results, and then just output the result. So what it does, it picks the items from this list one at a time, and for each round, it assigns an item into this variable result. Then it outputs the result, and then it picks the next item. And it keeps on doing this until it reaches the end of this item. In the end of the list, sorry. So this is really easy because we don't need any intermediate. We don't need to create any variables, any like intermediate variables. We don't need to specify any conditions, and we don't need to remember to change the value of index ourselves. So we don't need to do the modification part ourselves. We just state that for something in this sequence which is iterable. We can also use this with strings. So you can say that for character in name, just output the characters one at a time, and then it just outputs the characters one at a time. So this picks the characters from this string one at a time and assigns them one at a time into this variable character. So let's say that we have, so question, we have a name list. One more, and we want to find the first, say that we want to find the first person whose name starts with D, for example. We can do something like for name in name list, if name 0 equals D, then print the name, and then we can also break if you only want to find the first item that starts with the D, then we can break out, and then it displays Davis because that's the first one. How to convert string into a list? If you just want to, let's say that we have a name like David, you can do a list name like this. Use the list function, and then the end list contains all those characters as the individual items in a list. If you want to split something by something else, then that's what we're going to talk about later. So you can, for example, split the sentence into a list of words, but let's talk about that later. The list function is quite useful. It converts something that can be converted into a list into a list. Okay. Now the for loop is really useful, but there's a downside of for loop. Let's see that we have again the list of numbers. And we want to multiply them all by 2. We state that for number in numbers, number times plus 2, and then let's print the numbers. Let's see what happens. And now we see that the list of numbers hasn't changed. We still have values 1, 2, 3, 4, 5. Why? What do you think might be the reason? This might be a bit tricky, but still. Yeah, exactly. Okay, it wasn't that tricky at all. So we don't change any of the items in a list. If we want to change an item in a list, we need to assign something into item in a list. We need to state exactly like numbers 0 equals numbers 0 times 2 or something like. And now this changes the value of the first item to be 2. So now it's 2, 2, 3, 4, 5. In this case, we're not doing that. And we can change the value of this variable. That's perfectly fine. But it only changes the value of the variable. The variable isn't connected to the list after we have assigned a value in that variable. So there's no connection between this variable number and this list numbers, except that we assign those items into this variable one at a time. So if you want to change the list, yeah, we can append it to a new list and print a new list. Yeah, that one does the trick. But let's say that we want to change the existing list. And that's a good point, because it's really different to change an existing list or create a new list with same values. Again, something we're going to discuss more next week. Okay, so let's say that we want to change all those numbers, and to do that, we're going to need indexes or indices between 0 and 4. And the easiest way to create indices is by using a range function. And how it works. Let's do something like this. Let's just output the indices first. So range from 1 to 6 creates indexes 1, 2, 3, 4, and 5. And it doesn't create 6 because, again, the end value is not included. Meaning that range 5, if you don't provide the start value, it starts from 0, creates indexes from 0 to 4. And now these are the ones we want to use to manipulate the list. So we can write something like for I in range, and then let's get the length of the list. And now this creates all the indices that are present in this list, and then we can say that numbers I times 2, or just write longer version if it's easier to, times 2. And then when we output the numbers, now we see that all the values have been multiplied by 2. So now it's 2, 4, 6, 8, and 10. The I in this case is a variable. It's any variable. It doesn't need to be I. It can be index instead. This one works too. I is typically used for this one for sort of like historical reasons, because we've been used I in for loops since, I don't know, since 50s or 60s or something, I guess 60s. I is shortened for index, and it's typical to use it in for loop. And in this case, it's acceptable to use one character variable name because it's so often used. Yeah, we can use times equals 2, definitely. I just wrote it open because I thought that there's so much happening in this already that let's not overcomplicate it. But yeah, this one definitely works. It's exactly the same. Good question. We can also use range whenever, even if we don't have any lists. So we want to output numbers from 0 to 1000. Let's just do this. It doesn't create any list, but it does go through all the numbers from 0 until 1000. So range is useful whenever you want to iterate through a range of numbers, but you don't want to create a list containing those numbers. So range doesn't create a list. If you do something like this, if you output this one, you can see that it's not a range. It's not a list of items. It's not range from 0 to 10. If you want to generate, or if you want to create a list out of this one, you can use the list function, and then we have a list containing those values from 0 to 9. Also, can we make Python generate a random list? Yeah, we can do that, and we're going to talk about random in week 6 or 7, I think. So yeah, we can definitely do that. But let's not go there yet. We're going to need some new tools for generating random numbers or pseudo random numbers. Okay, so range is really useful. Range 10, yeah, always starts at 0, and this reason is that we can provide a 0 here, but if we don't provide a starting point, then Python assumes that we start from 0. So this is same as saying that start from 0 until 0. You can also start from a negative value if you want to, and then we get a list from -10 to 10, except that 10 isn't included, so it's 9 is the final one. We can also, there are, and in material, there are other things like we can provide a step for this one if we want to. So it's now it progresses in step of 2. If you wrote that R equals range 10, then yeah, oops, it just creates a range. You can output the range, but it does just output 0, range 0.10. So range is something we can iterate through by using a for loop, but it isn't something that's useful without converting it to something or iterating through it. So if you do a range like this and then output it, it just outputs the range 0.10. 0.10. So range is useful and so on. Then some final things, we can slice lists similar to substrings. So by providing start and end point, we can create sublists out of a list. Let's get back to this one next week as well. And immutability of strings is also something. Actually, let's see this one quickly. So just as a reminder, if you have a list like numbers equal 1, 2, 3, we can assign a value into a list like this. If we have a string, we cannot assign anything into a string. So this will give us an error stating that str object does not support item assignment. You can't assign anything to a string. And what I hope, also what I require you to remember is that strings are immutable. So it's impossible to change a string. You can create a new string based on existing string. So we can do something like this. P plus name starting from 1. And now it seems that we changed the first letter to B. But this doesn't actually change the string. We just create a new string based on existing string. And you can see the difference. In this case, we are assigning to this variable name. In this case, we are assigning to a single item in a list. And there's a big difference over there. Strings are immutable. Once we have created the string, we can't change that string. And that's the final thing for today about method replace, which is useful with strings. I'm going to show you a quick example. I have a sentence which says that little dog is sitting outside, and let's say that we don't care for dogs, we want to change it to a cat. We can do something like sentence equals sentence dot replace, and then replace the dog with cat, and let's see what the sentence looks like now. So now it replaces all occurrences of a substring with another substring. So if there are multiple dog words, dog sitting outside, then it changes those both to cat. So replace is great for a lot of occasions. It's also great for doing things like, let's say that we want to get rid of all the spaces in that one. We can do something like, let's replace all the spaces with an empty string, and then we just have all the words together. So it's great when you want to remove something from a string as well. By replacing something with an empty string, we can get rid of. And again, I'm sort of talking about replacing stuff in the strings, but we can't really change the string. Instead, we are creating new strings. So I want to show this one as well. Let's say that we have a name. We want to change the name to James Python, say name replace with James. What is the outcome? Does this work? Is Peter replaced with James? No, it isn't. Exactly. So it does output Peter Python. The reason for this is that this replace method creates a new string. And it needs to create a new string because it can't change an existing string. And what happens here is that we do create a new string where Peter is replaced with James, but we don't do anything with it. It's just sort of left hanging over there. We don't assign it to anything. So we can say that name2 equals name replace, and then we can, now we have a string James Python, or if we don't need the original string, we can replace the original string with this one, and then replace Peter with James. Again, it doesn't change the original string, it just creates a new string, and then we use that new string to replace the original string. So we replace the value in this variable, but the old string still remains somewhere in the memory. Let's get back to this next week as well. But this is important when you're using the replace, because this is not a syntax error if you're doing it like this. Python doesn't give you an error message, but it doesn't do anything visible as well. Still outputs Peter Python, and this is probably what the expectation for this. Okay. There are a couple of slides about formatting input, but I think we covered this already. And next week, we're going to continue. We're going to talk more about lists. Let's say, well, especially multidimensional lists. So we can store any items into a list. And if we can store any item into a list, we can also store lists inside lists. And let's see how that works. Then we're going to talk about references, about using lists with functions. And then we're going to discuss two new data structures called dictionary and tuple. But this week it's all about functions, and it's all about functions and lists, and then some new string methods. Do you have any questions? No. Next lecture is next week at the normal time. Is there some other information somewhere? Next Thursday at 10:15. Oh, okay, yeah. How to upload our homework? I think I can stop the recording now.